Okay, so we're going to actually solve this problem that we just finished ending with in the last video. Before I do that though, I want to go back to our original really easy example and show you a different way of solving it with the magic numbers, okay? We're still using magic numbers though, and no, they're not really magic. Okay, so looking at this trinomial we've factored already before, okay? What are the magic numbers? Oh, okay, two numbers that multiply to give 6 and add to give 5. And it's obviously 2 and 3. We can rewrite this middle term using the magic numbers. Okay, in other words, it's going to be like this. Okay, and we know it's going to be like that because we know that we get 4 terms and we collect those two middle ones to be that one single term. In other words, you would normally go straight to that, and I guess really if you to do it well, you can do it however you want. But I guess I could have put the 2 over the other side and the 3 on the other side. So put the 2 there and the 3 there. So I'd go x times x is x squared, and then x times 2 is 2x, and 3 times x is 3x. And that's where those numbers come from. Okay, so you can sort of see where those numbers come from, and I'll sort of show you how it's all going to play out here. So if I look now and just look at these first two, remember I said factoring by pairs is going to become really important? Today's the day. So just factor by pairs the first two. Yes, I know you can combine like terms, but it's not going to help us to factor this one on the left here. So we're going to factor by pairs, and you'll notice that only an x is common to both, and I'm left with x plus 2. And then looking at the ones on the right, I see that 3 is common to both, so I'm going to factor that out, and I'll look at that. I get x plus 2, and then that leaves me with x plus 2, if I factor that out front, and x plus 3. Okay? Way more work than you need to do for this type of problem. However, this same method is going to allow us to find the factors for the problem we have here on the left, the 2x squared minus x minus 3. So we still have to start with our magic number question. Slightly different though, okay? Our magic numbers are not going to multiply to give negative 3. They're going to multiply to give negative 6. Okay? That was actually the same thing we've been doing before, but because there was always just a 1 here, it was just 1 times 6, or 1 times whatever that last number is. Okay? I didn't tell you that, but surprise. Okay? So that's all I'm doing. Whatever the first number is here, 2 in this example, and then times negative 3, negative 6, that's going to be what my two magic numbers are going to multiply to give. So I'm still looking for numbers that add to give this middle number, in other words, negative 1, but they're going to multiply to give negative 6. So a times b equals negative 6, a plus b equals negative 1. And I think you could all see pretty clearly it's going to be negative 3 and 2. Okay, multiply to give negative 6, add to give negative 1. And we're going to write out that polynomial with those two terms mixed in there, so I'm going to have 4 terms instead of 3. Okay, and that's what I'm left with there. So my magic numbers have become the coefficients for my two x terms. And just like before, I'm going to factor by pairs now, and you can sort of see what's going to come out here. Okay, I can factor an x out of the first two, and then 2x and minus 3 don't have anything in common, but I have to factor something out, so I'm just going to factor out a 1. I know it's kind of like we're cheating a little bit, but it does work, okay? Because now you can see that I have 2x minus 3 as a factor on both, which means that my two factors are 2x minus 3 and x plus 1. Okay, and that method works every time the first time, which is why I like it the most, but I'll show you a shortcut later. For now though, let's just do another example or two. Okay, take 6x squared minus x minus 35 for example, and we have to try to find some magic numbers here. Now this is going to be a big problem because 6 times negative 35 is negative 210. It's a lot of factors there. So you need two factors of negative 210 that add up to give negative 1. That is this coefficient there. Okay. Well, to do that, we have to figure out all the different factors of negative 210 and see which ones have a difference of negative 1. So yeah, it might take you a little bit to figure them all out, but there are all the factors of 210, 1 and 210, 2 and 105, etc., etc. And obviously the only one that has a difference of 1 is these guys at the bottom here. And so let's see which one's going to be negative. Well, it's going to be the negative 15. Okay, well, I'm running out of time here for this video, but there it is broken out into two different terms. From here, see if you can factor by pairs and get to the correct answer, and I'll show you the next video what the answer is going to be.